All right, calculus 2. This is 4.7 optimization, and we have certain people coming in. So we have manufacturer needs to produce a cylindrical container with capacity of 1,000 centimeters cubed. The top and bottom of the container are made of different material that costs 0.05 cents. No wait, dollars. Sorry, 5 cents per square centimeter. While the sides of the container is made of material costing 3 cents per square centimeter. Find the dimensions that will maximize the company's cost of producing the container. All right, so first thing,
Buy it all.
do you guys know the formula for this?
Yes.
Surface area?
Oh, well, yeah.
Probably not, right?
Yes.
Okay, let's pretend like we don't.
Okay.
Tools, insert, page, there we go. All right, so if it's gonna be cylindrical, that means top and bottom would be what?
A circle and the same.
Circle, right? The area of a circle, right?
Yeah.
So there would be,
2.
so my surface area would be 2 pi r squared, right? So that's going to be top and bottom. So I'm going to have the top. I'm going to have the bottom. So I basically just like cut it out and sliced it and like laid it all flat, right? So I know from here I should have a R, right? And I know from here to here is wrapping around the circle.
What's the circumference?
That would be the circumference, right?
Yeah.
So I would be adding the circumference, right? This is a rectangle or a square, right? So it would be, the formula for circumference would be the distance from here to here, right?
Yeah.
So that would be what?
2 pi.
2 pi r, right? That's the circumference, right? That's circumference times what? The height. Yes?
Yes.
Yep.
Okay, good. So I had to come out and find a formula first. I had to make a formula out of it. So since I'm making a formula, that means I can, I know what it is I'm talking about. Sorry, all right. Okay, capacity. So the capacity, what does that tell me if I'm looking for the capacity?
Volume.
Volume, very good. So volume is going to be 1,000 centimeters cubed. Keep going to the wrong one. Anyway. All right. Top and bottom of the container are made of material that cost 5 cents per. So top and bottom are 5 cents per square centimeter. Side is 3 cents per square centimeter. Right? So square centimeter, that tells me that's going to be the area, right? So area of the top plus the area of the sides, right?
Yeah.
Okay, so they're going to be different parts of this function. So I know it's going to be whatever the area is here, so it'd be 2 pi r squared, and that's going to be times, what is it, 0.05?
Yeah. 5 cents.
5 cents. And this is the cost, right?
Mm-hmm.
Plus 2 pi r h times my cost over here, which is 0.03. So I'm going to be trying maximizing those things.
Minimize.
Minimize. Sorry. So I know that the volume has to also be included in this because the volume is going to be 1,000. So the volume formula is what? Volume is equal to what?
Pi r squared h.
So it's going to be pi, right? Come on, pi. Pi r squared h. Sorry, it's one of those days. Okay, so what don't I like here? So to be able to do this, I want to maximize this. So I want to try and substitute one of these so I can try to go through and figure out a couple different things. So first thing I'm going to try and get rid of is my h, because the h is only in one of these, right? The h is only talking about just the side length or the height of my container. It's not going to be the top and bottom. So if I replace everything in those values, I know that h should equal v divided by pi r squared. Yes?
Yep.
Okay, that's good. So I could actually get rid of some things here now, right? So I can get rid of the h. So I'm going to be maximizing everything, or minimizing, sorry. Minimizing everything for my r value.
Oh.
So let's go ahead and replace it. So I'm going to replace it. I'm going to do another one because I don't want to cram up this one. All right, so it's going to be 2 pi r. Sorry. Insert page. After. Okay. So I have my, so maximizing cost. So it's basically like C of r is going to be 2 pi r squared times 0.05 plus 2 pi r, and h is now going to be the volume over pi r squared, right? And that's going to be times what?
0.03.
0.03. So now, since I'm doing costs in terms of r, so I could actually go ahead and just do this for r.
Yeah.
So I'm setting it up. So let's go through and let's see, for this, I can clean this up a little bit. So it would be 2 r, or C of r is equal to what? So multiply those out. What's that? 10?
Yeah.
Yeah, 0.10, right?
Yep.
Pi r squared plus, let me see, the pi's will cancel, right? And v, do I have a value for v?
1,000.
1,000, right? It's going to be 1,000. So whatever that is going to be 1,000. So it's going to be 1,000 times 0.3, which is 30.
Yeah.
Yeah, 30, right?
Yeah. Yeah.
So 30 times 2 is 60. Now the r, this r will cancel, but I'm still left with
1R.
1 r in the bottom, right?
Yeah.
So everything else turns into over r. Okay, so now since we're trying to find this for r, right? Figuring out what that's going to be, so let's go through and take derivative. So that would be c prime of r.
Yep.
C prime of r would be 2. That's going to be 2, right?
Yeah, pi r
Pi r,
minus 60 over r squared.
so minus 60 over r squared. And what am I trying to maximize for? The r, right?
Yeah.
So maximize, minimize. So we're trying to figure this out. So where is mins and maxes always happen?
At a 0 when the slope is 0.
Okay, slope is 0, right? So I need to set this equal to 0 here, right? But to do that, I'm going to want to have a common denominator anyway, right? So let's algebra this a little bit. So this is missing an r squared in the bottom, isn't it? So if that's missing an r squared in the bottom, I could say c prime of r is equal to, so times r squared over r squared, right? It'd be 0.2 pi r cubed minus 60 over r squared. Did I lose anyone there?
Nope.
Okay, because I had to multiply by r squared over r squared, right?
Yeah.
Did I do it correctly? Okay, good. Just making sure. Okay, got some people looking at me quite intently. Okay, all right, so now set it equal to 0. 0.2 pi r cubed minus 60 over r squared. And I like that r squared at the bottom because I can get rid of it. Multiply both sides by r squared, right? So multiply both sides by r squared, so I'm going to get 0 is equal to 0.2 pi r cubed minus 60. So it's going to move the 60 to the other side, right?
Yeah.
Okay, 60 the other side, so it's going to be, alright, so it would be 60 equals 0.2 pi r cubed. Divide both sides by 0.2 pi.
Yeah, 300 over pi.
300 over pi. 300 over pi equals r cubed. So it's going to be r is equal to something nasty. Cube root of cube root of 300 over pi.
Number 9.772. No, wait, I'm sorry, that was the square root.
Yeah.
4.57.
Yeah.
Yes.
We get, what'd you come up with?
4.57.
4.57? 57, what's the next number?
1.
1? Okay.
0, but then that's 7 to the 0. So 1.
Okay, yeah, 571. There we go. What are my units?
Centimeters.
Centimeters.
And the cost is going to be about 20.
Okay, so now let's start off with the values. So I know how I now have maximized or minimized, right? This for my R value. So let's take a look. So for my R, let's go back a page. R is 4.571. So if R is 4.571, the top, so C of R, or my R would be 4.571, right? So plug it in, so it'd be, for this one, it would be 2 pi 4.571 squared times 0.05 plus 2 pi 4.571 let's go back because I have to find the H. And that's times 0.03. All right, so let's go back and find an H value now. So I have H is equal to this, right? So since H is here, I know it's going to be H is equal to 1,000, because that was my V, divided by pi times 4.571 squared.
Which is 15.234.
15.234.
Yeah.
So my cost
If I plug it in right, it's 19.6898.
So 19.69.
Yeah, exactly.
And what are my units on this one? I know it's money, right?
Dollars a centimeter, square centimeter?
Just dollars.
Just
Dollars per what?
Per
Cylinder. So per cylinder. So per container, right? Because at the very beginning of this, I started with a manufacturer needs to produce a cylindrical
container.
There we go. That word,
Yeah.
container.
per container.
Or per unit. Per unit would be good too. Not bad. We had to use two different formulas. We used the volume, we used the surface area together. We were able to isolate, get rid of one of my variables, and from there, could I have maximized this for height?
Yeah.
Yeah, you could have set up an equation.
I could have set it up for H instead, right?
Yeah, but
Why didn't I do that?
because there's only one.
There's only one H, right?
Yeah.
And over here I have an R squared, right? So if I have an R squared right here, that's gonna make it interesting because you're end up with square roots that you're plugging in, right?
Yeah.
So try to make it easy for yourself by getting rid of the one that you don't really need, or the one that you can get rid of easiest. All right, good. All right.
Snell.
These ones are my favorite.
These were on the AP test.
Yeah, they're always on the AP exam.
The answer is 25.
Yeah, just be done.
All right, so rectangle is inscribed in a semicircle of radius 2. Find the dimension of the rectangle that has the maximum area. So, maximum area, so what does that tell me? I'm looking for what? Yeah, you guys are on it, but I'm like trying to be like overly obvious about it.
You're maximizing.
Which?
Rectangle.
The rectangle,
X
thank
times
you.
Y, you know.
Thank you. Okay, because I've seen some of these, people actually did it for the circle instead. Like, I'm like, really? Come on now. Ugh. So, if I'm doing the area of the rectangle, I know that area will equal what?
2xy.
Very good, 2xy. Okay. What else do I know out of this?
Find where you think the restriction on the domain,
Okay.
basically.
So I know that I cannot. Can I go all the way to 2? Can x be 2?
Then y would be 0.
Then y would be 0. Can y be 2?
Y would be 2. Then x would be 0.
Then x would be 0. So I know that I have to limit it in there, right?
Yeah.
Alright, so let's see. What else do we know? The radius is going to be what?
2.
Radius is 2, right? So if the radius is 2 of the circle, I know that it's going to be from here to here is going to be 2, right? Okay, that's good. So the maximum I can get out of there, so half circle, right? So area half circle would be pi r squared divided by 2? Yes?
Yep.
Alright, so what else can I get from there? I know here to here is what? 2, right? Is it touching the circle?
Yes.
It is touching the circle, isn't it? If it's touching the circle, I know that one right there is going to be 2. Okay. So So I have a triangle there, and I know the edge is touching the circle, and the radius is going to be 2. So could I find the area of the triangle?
Yeah.
Yeah, if I find the area of the triangle, what would I do to actually find the area of the whole thing?
Multiply by 4.
By 4, right?
Yeah.
Why 4?
Because there's 4 triangles.
Yeah, I get 4 of those out of it, right? I can get 4 of those out of there. So if I could maximize that, let's see. All right, so just using the triangle, so I know the area of the triangle should be equal to 4 times x times y over 2. That's the area of a triangle, right? So that could also be another way of doing this, can I?
Yeah.
Yeah.
Yes.
Okay. Alright, so I still got that x and y though. What else can I do? I know that x squared plus y squared is equal to 2, right?
And, yeah.
Okay, it's always going to be like that. So let's do it for x, just because. So so if we're going to do it for x, let's get rid of y. So I'm going to say that y squared is equal to 2 minus x squared. And then y will equal to plus or minus square root of 2 minus x squared.
Oh. Shouldn't it be 2 squared? No, it's not.
2 squared, you're right, sorry.
It can't be. Well, yeah, but it never be.
Okay, thank you on that one. Appreciate it.
It was,
That would screw me up later.
Yeah, that would really.
I know. I hate making a mistake on like the very first setup and then be like, okay. All right, so now we have everything there. But since I'm talking about areas, I'm probably only going to be dealing with the positive side, right? Yeah, so I'm only going to be dealing with the positive side. So let's replace that. So if I replace that, I know I'm going to be working with my area is equal to, now the 4 and the 2 is going to turn this into 2, right? 2x times 4 minus x squared to the 1/2. Anyone lost? Confused? Question what I'm doing? Always question. Shake your head. Have no clue what's going on. SMH. Are we okay?
Yeah.
No, that's, I think it's right.
Okay, so now it's if I'm gonna do this, what would I do with this now?
Derive it,
Yeah, take the derivative.
Set equals 0.
So what did I say? I said a was equal to
2x times the quantity of 4 minus x squared to the 1/2.
okay, so that's gonna be a product with the chain, right?
Yep.
Okay, so let's call this one F, call this one G. So F prime would be 2 and G prime would be 1/2 quantity 4 minus x squared to the negative 1/2 times negative 2x.
Yep.
So G prime is negative x times 4 minus x squared to the negative 1/2. There we go. Clean that up a little bit. All right. So F prime G. So it's so that's going to be dA d
Well.
x, right?
Yeah.
Equals, I lost it. Oh, there it is. 2 and 4 minus x squared 1/2 plus my G prime F. So it's going to be a 2x times negative x quantity 4 minus x squared to the negative 1/2. So it looks worse than it actually is. So I'm gonna clean this up because I need this space here. All right, so dA dx is going to be 2 quantity 4 minus x squared 1/2, and that's going to become a minus 2x squared over 4 minus x squared to the positive 1/2 down here. Now, to be able to do this again, I need to have common denominator, because minimize, maximize, optimize, I need to be able to have common denominator, have one function there, right? So I'm going to multiply top and bottom by this, the common denominator, right?
Yeah.
So if I'm multiplying this to the 1/2 times another 1 to the 1/2, that's going to give me a whole, isn't it?
Yeah.
So that's going to make it a whole. So dA dx is equal to, so it's 2 quantity 4 minus x squared, that's a whole, because common denominator, minus 2x squared over 4 minus x squared to the 1/2. Multiply both sides by 0, and I'm sorry, set it equal to 0, right? Set it equal to 0,
Yes.
and then distribute this. So it's going to be 0, right? Equals, so the denominator goes away.
Yeah.
So I'm left with 8 minus 2x squared minus 2x squared over nothing.
It's just under. Yep. 8 minus 4 squared.
Okay, so I get,
8 over.
let's see, 0 equals 8 minus 4x squared.
Is 2 equals x squared.
So 2 equals x squared, right?
Yep. And then rad 2.
So So with the 2. So plus or minus square root of 2. So if x is equal to plus or minus square root of 2, what does that tell me? In this equation, since I was dealing with the circle, right, and it is on a graph, it's going to go both directions, right? But since like I said, I'm only going to talk about the positive part. So I know x should be 2, but it should, or I'm sorry, rad 2, and the other side it should be negative rad 2. Let's go back a page. So let's see. Let's solve for y now. Y is equal to plus or minus, but it's actually just going to be the plus. 4 minus rad 2 squared. So what's that going to give me?
Rad 2.
Rad 2. It's going to be rad 2, right? But remember, we're maximizing the area. So for maximizing the area, we'll go black here. All right, so this value right here, from here to here, would be 2 rad 2, right?
Mm-hmm.
And then the height going up from here to here would just be rad 2. So the maximum area, so let's take a look. So my maximum area, so area would be 2 times 2 rad 2 times rad 2. So my maximum area should be...
Would it be 2 rad 2? That sounded stupid, but
Rad 2.
would
Okay.
it just be 2 rad 2? Because we already, in the area formula, you already accounted for the fact that there's 2 x's.
Oh, you right. Good job. Good job. I'll throw some candy at you here in a second. Good job. All right, so I'm going to come up with what? 4 units squared.
That makes sense because they're used to.
Yes.
Yeah.
So if it's maximizing the squared inside of the semicircle, would that mean the theta value is going to be 45 degrees if it's the max, and if it's 45 degrees, it's 45, 45, 90. And if it's that, then x can be radical 2. So then the side lengths are going to be, so like the x would be radical 2, the y would be radical 2. So then you multiply by radical 2 to find the hypotenuse. So then that's why the radius would be 2, or the radius.
Yeah.
So you could not do all that work and you'd be able to get the right answer, right?
Basically.
So is that going to be standard for all? Just set theta equal to 45 degrees and then just find x and y like that. Then done. Goodbye. Instead of doing all that. Because that seems a lot easier.
Okay.
But is
So
that
you-
going to work all the time?
Maybe.
Okay.
I don't know. All right. Like and subscribe.